Okay, Team Bio. So I recorded the screencast earlier, and for some reason, the first half of it deleted itself, so here it is again. I'm sorry, I'm not going to write everything out again. I'm just going to use the slides that already exist. So basically, this is an introduction to evolution, and we've already talked about this a little bit, but evolution, again, is the change in the genetic makeup of a population over time. So we were all dealt a certain genetic hand at birth, or I guess at conception, really. And that is unchangeable. But what can change is the frequency of alleles that we see in a population over time. So again, evolution acts at the level of the DNA, so mutations in the DNA lead to changes in RNA, which lead to changes in protein, and then natural selection acts upon the phenotype of those organisms. So organisms that have proteins that allow them to survive and reproduce better than other organisms then go on to leave on more offspring and thus more DNA. So the frequency of this allele goes up. Or contrary to that, if a protein is not so good, then that leads to a less fit organism that leaves behind less DNA, and therefore we see less of that allele. Or fewer of those alleles. I think that's the right grammar. Okay, so introduction to evolution. Boom. Next slide. So, some evidence that we have for evolution, primarily, or the first piece of evidence that we have, is the fossil record. So if you look at sediment, this is a beautiful depiction of sedimentary rock here, and these rocks at the bottom are the oldest, and these at the top are the newest. And if we look through the layers of this rock, we can track one organism over time and see how the morphology or the phenotype changes over time. Now, I said before that evolution is acting on the DNA, and unfortunately, for fossils, we can't analyze the DNA and see how it's changing. We can just look at phenotypes. But, as I said before, changes in phenotype are a good indication that the DNA is changing as well. And so, an example of that are scallops. I know they're not super interesting, but if you can see, these ancient scallops bear resemblance to the scallops that we see later in the fossil record. Now, the fossil record is not complete by any means, and that's one of the biggest strikes against it by people who are creationists. However, it is becoming more complete every day as new fossils are found and categorized. So while this is not a totally, not foolproof, that's not the right word I'm saying. I guess complete is the word I'm looking for. This is not a complete record. It is good evidence for evolution. Okay, the next piece of evidence for evolution is homologous structures, and that's where the second part of the screencast kicks in. So I'm going to stop it here, and you can pick up on the second link.